Okay guys, so here's the plan for today. You see you have 3 AP questions here, so you have this one and then 2 on the back. So we're going to do the first one together, and then you guys are going to do the other 2 on your own. So take a look at the equation. It says we have the tide removes sand from the beach at a rate modeled by R of T. Then it says a pumping station is adding sand to the beach at a rate modeled by blah, blah, blah. So the first thing that I'm going to notice here is that this is removing sand. This is adding sand. Okay, so let's think about that first. Then it says R of T and S of T both have cubic yards per hour and cubic yards per hour. So both of those are measuring the amount of sand being removed per hour. Then it says T is from 0 to 6. And then it says at time 0, the beach already contains 250 yards of sand. So that's there from the very beginning. Okay, so first thing that I'd like you to do is go ahead and type those into your calculator. So my removal rate is going to be Y1. My add the sand back in rate is going to be Y2. So take a second and do that for me, please. So my Y1 here is going to be 2 plus 5 sine. Alpha y equals, to pull up my little fraction bar, 4 pi x over 25. Oops, wrong spot for that. So 4 pi x over 25. Question number 2, alpha y equals, we're typing in our equation, 15x on top, 1 plus 3x on bottom. Okay, so next thing I'm going to do is adjust my window. So it tells me that I'm mainly just looking from 0 to 6. So I'm going to go from 0 to 6. And then I'm going to look in my table just to see how big my y values are. So notice that I'm starting at 4. And then it looks like my numbers really don't go much above like 6.99. Okay, that's like about 7. So in my window, I'm going to adjust my y's to be from -1 to 10. Now, keep in mind that these aren't magic numbers. You're just kind of estimating to kind of be able to see where you want to set your graph. So, there's my first graph. And then here's my second graph. Okay? So, this first one was R of T. I'll call that Y1 R of T. And then the second one was my Y2, which is S of T. Okay. So, part A says, how much sand will the tide remove from the bank during this 6-hour period? So, if I want to know how much sand, think about this is in cubic yards per hour. Cubic yards per hour. So, if I only want to know how much sand, then I need to remove this bottom unit. Remember that that means it's an integral. Now, for the 6-hour period, it'd be 0 to 6. I'm only wanting to know how much was removed, so I'm just going to integrate R of T. Okay, then I'm going to do that in my calculator. Now remember, R of T is my Y1, so I'm going to do it in my normal calculator mode, math 9, 0 to 6, Y1, and then dx. So just like that, 0 to 6, Y1, dx. So I have 31.8159. And then that would be cubic yards of sand removed. Okay? So how much sand will the tide remove? This much. Okay, then it says indicate units of measure. So I did that here by saying cubic yards. Okay, then it says part B. Write an expression for y of t, which is the total number of cubic yards of sand on the beach at time t. Now notice, if they're keeping your t generic, that means that they just want you to leave a letter in that spot. So, I'm going to put y of t equals. Okay, the first thing that I'm going to do is consider how much sand is already on the beach. It says there's already 2,500 cubic yards. Okay, plus. Then I'm going to add in all the sand that's being increased. and I'm going to subtract all of the sand that's being removed. But keep in mind that since these are both rates of cubic yards per hour, I need to put an integral on them to know how many actual cubic yards of sand are being removed or added. So I'm going to do an integral from 0 to t, keeping my t kind of ambiguous here. And then I'm going to do a positive s of t because these are being added. And then I'm going to do a minus on my r of t because those are being removed, dt. Now you also could have done 2500 plus the integral 0 to t of s of t, and then minus the integral from 0 to t of r of t. Okay, it doesn't matter if you group them together or separate, so either one of those would be fine. Okay, part C. So we're done with part B already. Find the rate at which the total amount of sand on the beach is changing at time 4. Okay, so notice they're asking me for a rate, but keep in mind that these are both already rates. So what I need to figure out is the overall rate, considering the fact that there's some coming on and some going off, both at the same time. So for my rate, I'm going to need to say, okay, well, if I want to know at 4, let's go back to my calculator and my table. Okay, at 4, it says that R of t is 6.5241. Okay, but then for my S of t, which is my Y2 here, says that my S of t is 60 over 13. Now, obviously, that is not super helpful, so I'm going to go into my mode here, and I'm going to change this to be... I'm wondering why it's in like fraction form instead of just a decimal. Here we go. So I'm going to switch it to answers to be in decimal form. Okay? So, still with this? Okay, so I'm just going to divide 60 by 13 to know what that is. So 60 by 13 is 4.6153. Okay, so my tide is taking the sand away at this rate, and it's bringing it in with this rate. So my overall total rate would have to be this minus this. So I'm going to call this, think about, if y is the number of cubic yards of sand, I'm going to call this y prime of t. And it would be 4.6153 minus 6.5241. Okay, so I'm going to write that right here, 4.6153 minus 6.5241. Okay, so I get overall negative 1.9088. Now you might be wondering, oh no, well why did that come out to be negative? Okay, that's a great question. Let's look back at the graph. So if I'm back here in my graphing mode and I'm looking at 4, 4 is about right here in my graph, about right here. Okay, we'll just say that's about 4. So then in this section, think about, this is my removal function. So if it's being removed faster than it's being pumped back in, then what that means is that overall the amount of sand at that time is decreasing. So this is not really part of the question, but just to make sure you understand it, I'm going to write out then at t equals 4, the amount of sand on the beach is decreasing at an overall rate of 1.9088 yards cubed per hour. So overall, at that point in time, we can see that our amount of sand on the beach is decreasing. Okay, let's go on to part D. Okay, so part D says, at what time t is the amount of sand on the beach a minimum? What is the minimum value? Justify your answers. Okay, so let's look back at our graph here for a second. So if I'm looking at this right here, on this interval, this is my removal function. Okay, so as you can see in this first part, my sand was going in at a higher rate than it was going out. That means that overall my rate on this section was positive. Okay, but then on this section I can see that my removal function is higher. That means that the amount of sand on the beach was overall decreasing, or the rate was negative. Okay, but then I can see that over here on this side, they switch again to where overall my rate would be positive, because my in function ends up surpassing where my out function was. Now, good news and bad news. The good news is that I can pretty easily find these two intersection points. Okay, but the bad news is that on the example that we worked the other day in class, there was only one sign change. So that meant that we could automatically determine that that particular value was the greatest or the least, because it was the only one. Given that I have two, that is no longer the case. I'm going to have to do a candidates chart. So I'm going to find my two intersections. Second trace 5. Oops. Okay, so I'm going to do second trace 5. Enter, enter, enter. Okay, so the first one that it gives me is this value over here, which is t equals 5.1178. Second value over here, second trace, option number 5. Enter, enter, and then for my guess, I'm going to type in 0.5 just because it's back over here. So that one comes, oh, it gave me the same one. Second trace 5, enter, enter, and then I'll just put 0. Okay, second trace 5, all the way back over here. Just keeps giving me the same one over and over again. Okay, so enter, enter, enter. What the heck? Do these cross over here? Intersect, enter, enter. What the heck? I do not know why I could not get my calculator to find this other value. This is a tragedy. Okay, I'm going to switch calculators. Brief pause. Okay, hopefully your calculator's not doing stupid things over there. 2 plus 5 sine 4 pi x over 25. And then down here we're doing 15x over plus 3x. Okay. Window we did 0 till 6. We did this -1 till about 10. Graph. Okay, there's our first one, there's our second one. Okay, so I guess maybe they just don't intersect over here. I don't know what the deal is with this. Okay, well, even though it's sad that this point, for some reason, is a mystery, and we've now spent like 2 minutes trying to find it, this is actually going to be our minimum, and here's why. It says, what is the minimum value? Keep in mind that this is, thankfully, the negative to positive sign change. This one over here is a positive to negative sign change, so this one is actually a maximum. So even though it's totally annoying, and I don't know why we can't find that point, this is actually the one where the relative minimum occurs. Now, keep in mind that a relative minimum is not an absolute minimum unless it's the only place where you have an extrema. So since I have a max, I'm going to have to do a table. So let's set it up down here. So 0 and 6 are my endpoints, and then 5.1178 is also one of my points. Now from here, I'm going to put my time here, and then I'm going to find the amount of sand on the beach. So at 0, we already know how much sand was on the beach. It said there were 2,500 cubic yards of sand. Okay, so now go down to our critical number. We're going to need to find how much sand is on the beach at that point. So it would be the 2,500 that's already there, plus the integral from 0 to 5.1178 of the amount of sand going in, which is S of t, but then minus the integral from 0 to 5.1178 of the amount of sand that is going out of the beach, which is our R of t. So I'm going to type that in here, plus math 9. Now remember what I said, you can put these together or you can do them separately, it really doesn't matter. The one thing I do have to be careful about is that this is actually my y2, this is actually my y1. So I'm going to put them in the same integral, but I have to remember to put my y2 first. So the amount of sand on the beach at our relative maximum is 2,492. 2,492.36. Okay, now we need to find the exact same thing, but at 6. So I'm going to push second enter, and then I'm just going to change this upper value to be a 6. So the amount of sand at 6 comes out to be 2,493.2766. Okay, and I don't want to be a hypocrite here, so I'm going to go to 4 decimals. So then looking at those two values, I just want to see which of those is greater. Well, I can see that this one is clearly the greatest. Actually, no, this one is clearly the greatest value. So you would say that even though I have a relative max at these two values, the sand is actually the biggest at the beginning. So I would put my absolute max amount of sand. Oh wait, hold on. We want a minimum. I don't know what I'm doing. Okay, look at the question. It says, where is it a minimum? So come back down here. We actually then want this one. Okay, it's been a long day. I don't know. Okay, so absolute minimum value is 2492.3694 cubic yards at t equals 5.1178, and that would be hours. Okay, now keep in mind that here it asks you for two questions. It says at what time is the sand a minimum and what is the minimum. So it's actually not that big of a deal that you had to make the chart, because you were going to have to find this number anyway. Okay, good job.